Let's look at a question. The question says a shopkeeper buys two varieties of rice at 10 rupees per kg and 20 rupees per kg. He mixes them in the ratio 3:2. What is the cost per kg of the mixture? Now, we already mentioned that it is the ratio that matters and not the actual quantity. But we can assume it to be 3 kgs and 2 kgs for the sake of simplicity, right? So you can just logically reason out that if you're getting that 5 kgs of mixture, what is happening is that you are spending 10 into 3, 30 rupees on the first variety of rice. For the 3 kgs, you're spending 30 rupees. And then you're also spending 20 into 2 for the second variety of rice. So your total expense is 30 plus 20, 40, which would be 70. And when you do that, by the time you do that, you will have 2 plus 3 or 5 kgs of mixture, right? That will be 70 by 5 is equal to 14 rupees per kg. That would be the weighted average, the cost per kg of the mixture. Now, how do you normally find the price of every line on your grocery bill? You have a rate. In this example, 10 rupees kg per kg is rate and 3 kg is the quantity that you have bought, and the price for that item on your bill would be price is equal to rate into quantity, right? So essentially what I've done here is there is a rate 1 for the first variety and the corresponding quantity 1, rate 2 into quantity 2 by Q1 plus Q2. This is the average price. It's just I'm just changing letters. It's the same formula, but I am writing in terms of rates. I just want to point out that while you're probably taught, a weighted average is an average of averages, I just want to expand the definition and say that a weighted average is an average of rates. An average of rates. That is all. It is the same formula. I'm just changing the letters around, right? So that is how you got your 14 rupees per kg. All fine. I just want to introduce another way of doing this. The question can also be solved by using a number line approach. You can find weighted averages using a number line. The approach is like this. You have to take the rates, R1 and R2 are your rates, 10 and 20 rupees per kg. You have to take the rates on the number line. What is the corresponding quantity ratio? The quantity ratio is 3:2. Take that ratio 3:2 and you want to invert this ratio. Invert it so it will become 2:3, and you want to divide the distance between the two rates. The distance between 10 and 20, you want to divide it in the ratio 2:3. The distance between 10 and 20 is 10 units. When you divide that in the ratio 2:3, you will get the values 4 and 6. And the weighted average that you're trying to find is basically 4 units to the right of 10. Or alternately, you can say it's 6 units to the left of 20. Either way, your answer is 14. So I'll repeat what I did. You took the rates on the number line. You have the quantity ratio. Flip the ratio and divide the distance between the rates in that flipped ratio. And you'll get a point in between. That point is your weighted average. Why does this approach work? And why should I flip the ratio? The latter question can be answered in a very simple, non-quantitative way by saying this. We've already seen that the mixture should more closely resemble the more abundant component in the mixture, right? For that to happen, the distance should actually be less on the side. Towards the distance should actually be less towards the more abundant component. And for that to happen, you have to flip it. That's not a good enough example, but a very simple non-quantitative way of understanding it. A detailed, rigorous explanation as to why this number line method works, I'll be doing in a separate video.